It's your friendly math tutor, Miss C here, and today we are graphing quadratic equations in minutes using our knowledge of the quadratic's parent function, y equals x squared. So let's start by looking at the table of values for y equals x squared. Hopefully you're noticing a few things. I'm noticing that we have the lowest point of our graph at 0, 0. This point is called the vertex. So the vertex is really important because it creates something called the line of symmetry. So the line of symmetry always passes through the vertex. And on this graph, you can see it. I just popped onto the graph and that dashed bright blue line. And what this does is it creates two symmetrical sides for each of our graphs. So what I mean by that is if I look at these three values here, and these three values here, you're going to notice that they're the same. You have a 1 and a 1. You have a 4 and a 4. You have a 9 and a 9, and the pattern will continue to repeat. So what's interesting about this, as those values happen, when these two values are equidistant from 0. So you can see when the x value is 1 unit away from the vertex, the y value of this particular graph is 1. The next value is exactly 2 units away from the vertex, and the y value is 4, and the pattern repeats. So let's go ahead and graph this. Let me grab my pen. And just to be sure that we all know what the vertex looks like, or the vertex and then our graph looks like. So here's the vertex at 0, 0. This x value is 1 unit on the x-axis away and then up 1. Okay, we're not doing slope here. We're looking at a pattern. So you're going to notice those two y values are exactly the same. Our next value is 2 units away from the vertex. So 1, 2, and then it's up 4. 1, 2, 3, 4. So this is not linear because it's now not going by the same amount, right? So this is quadratic. And then the next value is 3 units away from the vertex. So here's the vertex, 1, 2, 3, and all the way up 9. And we know that if this one is 3 units away from our line of symmetry, this one is 1, 2, 3 units away from our line of symmetry. So I'm going to go ahead and connect these. My connection skills are not great. This upward facing parabola, the parent function, if you were graphing this or doing this on paper, you'd want to make sure that you go through all the lines, but my graph is less than perfect. What is really important to notice here is if you folded your graph on this dashed blue line, both sides would fold on top of each other. So you're going to notice that, let me grab a different color pen here, that this point is exactly 1 unit away from the line of symmetry, as is this one. This is exactly 2 units, as is this one. This one is 3 units, as is this one. So what that means is when we're graphing, using the parent function as a guide, we just follow this pattern over and over and over again. So let's get started with that. So we are graphing this quadratic function that's written in vertex form. So let's review really quickly how we're going to think through this. So here's the table of values we just talked about for reference. And here's the way that I think it's easiest to start to quickly graph a quadratic. So the first thing I want to do is I want to find the vertex. So as a reminder, if you haven't watched any of my other videos or you haven't learned this, the way you find the vertex is the vertex happens when this part of the equation equals 0. So what value does x have to take on for that to happen? Well, the opposite of 3 is negative 3. So that's the x coordinate of our vertex. So negative 3 plus 3 is 0. 0 squared is 0. And then we're left with less 8 or minus 8, and that becomes the y value. Okay, so if I'm going to graph this, well, before I graph that, I'm going to also find the line of symmetry. The line of symmetry is a vertical line, completely vertical. So it's an x equals equation. And it's always x equals the x coordinate of our vertex. So our line of symmetry is negative 3. So I'm going to go ahead and plot my vertex. So I'm going to go over 3 to the left and down 8. So here's our vertex right here. And I am also going to go ahead and put our line of symmetry on here because, as we learned in the last video, or the last part of this video, we know that points are equidistant from the line of symmetry. So, okay, we're going to do our first set of points, and I'm going to do those in orange. So, remembering that exactly 1 unit away from our vertex horizontally, we increase our y value by 1. So I'm going to come over 1 and up 1, and that gives me my first value. Since this is 1 unit away, I'm doing the same thing on the other side. Okay, so that's our first point. And I'm going to grab another color. We'll do blue here. The next time we're going to be 2 away from our vertex. And when we do that, we're going to be, oops, that's 2 right here. We're going to increase by 4. So I'm going to go over 2, and then we're going to go 1, 2, 3, 4, over 2, and 1, 2, 3, 4. So we're looking at the behavior of our graph, and it behaves, what's beautiful about it is it behaves this way every single time. So the values are very predictable. The next one, we're 3 units away and we go up 9. So I'm going over 3 and I'm going to go up 9. We're at -8, so up 9 is here. So I'm 3 away, 1, 2, 3. So I have to go 1, 2, 3 over here. And now this is the graph of our parabola. So I'm going to actually grab a thicker, pen, and maybe I'll be a little more accurate connecting these points. So here we go. This is a sketch of our graph in vertex that was written in vertex form that we quickly put together so we know what this graph looks like. So if you already have this down from the last explanation, go ahead and skip to the next chapter in the video, and that shows you how to do the same process when you know the 2 roots or x-intercepts. If not, and you want to practice, you could pause this video and see if you can do this on your own, or you can walk through it one more time with me. We're going to be going much more quickly this time. All right, so let's go ahead and find the vertex. I'm interested, oops, I switched screens by accident. I'm interested in what makes the parentheses equal to 0 for x. In that case, it is +2. When that happens, I am left with 3. So 2, 3 is our vertex. That means our line of symmetry is at x equals our x value, which is 2. So I'm going to go ahead and plot those really quick. So 2, 3 is right here. And then our line of symmetry is here. Okay. All right. So now there's something unique about this graph that we did not have in our last graph, and it's this negative sign right here. That means that this vertex is a maximum. This is the highest point on our graph. So our parabola is going to be facing downward because this graph, that negative sign, makes this a reflected graph. So we're going to go ahead and we are going to do the exact same process, except what's going to happen is our points are going, instead of going up, we're going to be going downward. So we're going to use the same principle. 1 unit away, I'm 1 unit higher, right? So I'm going here and then I'm going down. I guess higher, lower if it's reflected here. So these should be on the same line, exactly 1 unit away from our line of symmetry. At 2 units away from our vertex, that puts us 1, 2 over here. We're going to be 4 units down from where our vertex was. So we're at 1, 2, 3, 4, and then 1, 2, 1, 2, 3, 4. Okay, and then 3 units away, like we did on the last one. If we're 3 units away, we are 9 units down from our vertex. 1, 2, 3, all the way 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if I'm 3 over here, I'm going to be 3 over here. And then all we're going to do is connect these points. Oops. This is shockingly difficult to do on a computer screen. It feels harder than on paper. Okay, and that is how you sketch this graph. This should be like a subtle U like this. Okay, let's try this with factored form. We now have factored form. So factored form's a little different, but we still use the parent function, y equals x squared, and its behavior. The difference is we're going to start by finding the roots first. So finding the roots, so those are our x values. So we're interested, as a reminder, in what makes each of these 0. So we know that 3 minus 3 is 0. So 3, 0 is one of our roots, and then -1, 0 is the other. So the vertex, what's interesting about this is we're still going to try to find the vertex and the line of symmetry. And what I know about the vertex is it's equidistant between the two roots. So I'm going to go ahead and plot these. So we know we've got a root here at 3, 0 and at negative 1, 0. So we're just trying to find the middle. So the middle of those, right, is going to be here at positive 1. So I'm going to draw my line of symmetry because that's going to be our line of symmetry. Okay, so x equals 1. So that means our vertex happens when x is 1. Okay, and now we just need to find the y value. So I'm going to come back up here and I'm going to substitute 1 everywhere I see x. And that's how I'm going to find my y value. So 1 minus 3, I'm going to come over here, is negative 2 times 2 is negative 4. So my vertex is right here at 1, negative 4. And now we follow the same pattern that we did before. So let's see if we can do this really quickly without using our chart, though it's here for your reference. So we're going to go over 1 and up 1. That's our first point of symmetry. Ooh, and that gives us our y-intercept as well. Okay, we're going to go over 2 and up 4, and those are our roots or our x-intercepts. And then we have one more to plot. And those are going to be over 3 from here and up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, here. And then 1, 2, 3 from here. And then we can just connect these points. And that's how you quickly sketch a parabola when you have your equation in factored form. Let's try one more again on the next one. You can try this on your own without me. You can fast forward to the end and see if you did it right, or you can walk through with me. Keep in mind, this one is reflected. It's got a negative in front, so it's a slightly different. Okay, so here is our table of the parent function for reference, and we're going to do this the same way we did on the last problem. We are going to start by finding the roots, and then we are going to go ahead and find the vertex and the line of symmetry. So our roots are 2, 0 and 4, 0. If you need a quick refresher on this, I do have another video on how to find the roots. Okay, our vertex is going to happen at 3 because that's directly between 2 and 4. So I'm going to plot these on the graph really quick for reference. So here's 2, here's 4, and then I'm going to sketch in our line of symmetry. I know this seems like a tedious task, but I had students do this forever, and it's super helpful because it's really easy to see if you're symmetrical or not. So I would suggest taking the extra time to do that, even though it might take, 2 seconds longer. Okay, to find the y value of our vertex, I'm going to go ahead and plug 3 in everywhere I see x. So we end up with, I'm running out of room here, negative times 1, which is negative 1, times negative 1, which is 1. Negative 1 times negative 1 is 1. So our vertex is at positive 3, 1. So I'm going to go ahead and plot that. If I said negative 3, it's positive 3, 1. So here's 3 and up 1. Now, just drawing your attention one more time to the fact that this is a reflected parabola. That means instead of going upward with our pattern, we go downward with our trends here. So we already have gone over 1 and down 1 to get our first 2 points. And I forgot to say that our line of symmetry is x equals 3, which I already sketched in green. Okay, our next one, we're going over 2 and we're going down 1, 2, 3, 4. I'm 2 over, I'm 2 over. This is how I would do it if I were trying to do this quickly. And then for my third point, do this in orange, I know that I'm going to go over 1 more. So I'm going to do this slightly differently. Usually when I teach this initially, I go from the vertex, but sometimes counting is just annoying. So I'm going to go from 1 more over from my blue dot, and then I'm going down. This is a distance of 5. So 1, 2, 3, 4, 5 here. And I'm 3 over, 1, 2, 3. And I'm 3 over here. Okay, so these should be completely symmetrical. And if I wanted to check, I'm at 8 units from 0 plus 1 is 9. So that gives me this 9 that I'm looking for. And then when I sketch this, I'm just going to hit all three points that I plotted on each side. And remembering that if I fold it along this green dashed line, my line of symmetry, I should end up with the graph folding on top of itself. If it doesn't look like it does that, you should try this again. All right, that's all I have for you today. Thank you for quickly graphing quadratic equations with me using your knowledge of the parent function. Make sure to subscribe for more videos. Till next time, remember, you've got this.